Good morning. Welcome back to the JagCorner. Good to see you. If you're already watching, if you're watching this after the fact, thanks for watching these videos. We last week we did a lot of games. This week we're going to do some programming. You can see down there in the bottom left corner, I have that Matrix Screensaver that we were working on a couple weeks ago. I'm pretty much done with that, and I'll in a moment here I'll go over that and show you what options I put in there. Um, I wasn't able to fix the flickering thing that I was hoping to fix before. I actually got, and I may have mentioned this on a previous stream, but I finished what we started a few weeks ago and found out that it was actually a lot slower uh, than it ended up, than I thought it was going to end up as. And so I actually reverted back to my old code. Um, Cleaned up some things and then added some options, and so it's working fine. It looks fine. I've had some people comment that the flickering actually looks kind of cool. It's a natural byproduct of how I'm doing it. Anyways, we'll get into that in a little bit. I'm just scanning the forums here really quick to see if there was anything I missed. I have a lot of email updates, but sometimes there's old threads that I'm not following. Let me jump over to that here really quick. There's old threads that I'm not following that sometimes pop up. There's been an interesting discussion on bringing Xenocrisis over to the Jag. If you don't know what Xenocrisis is, well, I think they have a screenshot here. It's a twin stick shooter, top down, kind of like, what was that game called? I've actually never played it, but it's Smash TV or something like that. It's a little bit violent. It's top down, and you go from room to room, and there's new challenges each room you go to, if I remember correctly, based on videos I've seen. If somebody's played it, they can probably explain it a lot better than me. But Bullet21, good morning. And Matt Smith, good morning. It's good to see you. Oh, yeah, and if you're watching this after the fact, or if you're new to the channel, I don't think anybody in the chat's new, but my name is Will Thorup. I'm an artist and programmer on the Jag for a group called BitJag, and eventually we'll release another game for the Jag. So I have been working on Crescent Memories, our next game. Sorry, I probably shouldn't be changing the size of that. I have been working on it. I've been making some slow progress on it. There's nothing that I want to be sharing on the stream right now. I will eventually do some streams on that again in the future, but for now we're going to be working on this test suite thing, and we're going to be working on bringing the Mystify screensaver to the 64-bit platform, the Atari Jaguar, and so that's what we're working on today. I haven't given it much thought, so hopefully we can get pretty far today. It's just really the reason why I want to do this screensaver is there's some line drawing routines in the removers library, and I haven't done anything with that yet. And so this is an opportunity really for me to learn how to use those functions. They should be pretty straightforward. Like, it shouldn't take long to actually learn that. But I am curious to see if they're fast enough to do this screensaver. And so I haven't thought about how I'm going to approach it too much. I have a few ideas, so hopefully we can actually get somewhere with it today. I think we can. I think we'll get things at least moving today. At least one set of lines will get moving. So anyways, yeah, so they've been talking about, somebody's been suggesting, I don't think anybody's actually started on porting this game to the Jag, but it'd be cool to see. It's a fun game. I think I have it on my Switch. I may actually have a physical copy on my Switch now that I think about it. It's a really fun game. I really enjoy it. Let me know if you've played that before. The Jag already has a game that's similar to that. It's just the top-down twin stick shooter. It's called Total Recall. Or not Total Recall, that's a movie. Total Carnage, there we go. Total Recall is pretty cool too, but Total Carnage isn't, in my opinion, isn't as cool. I don't enjoy it quite as much. It feels really unfair in a lot of ways, if I remember correctly. We'll have to stream that and see if my memory is correct. Saw the demo you did for Crescent Memories at PRGE a while back. Cool! It's good to finally meet somebody who saw that. What state was it in? I think Yeah, I think I had all 3 games available, didn't I? Or was it just Audit? It may have just been Audit Will Be Watching. I can't remember what I had built for that. It may have been all 3 games that I had set up for that. I can't remember, but I got a few pictures from Albert from Atari Age because he hosted the game that year. But oh, that's good. I'm glad. It's good to meet somebody who played it. I saw photos of people playing it, and so I know people have played it. What did you think? You can be honest. It's Audit Will Be Watching definitely isn't a good showcase piece because it's a little bit slow. Takes a little while to get into. But did you play Flappy McFur? Oh, we may talk about that here. Yeah, there's not a whole lot of updates on Twitter either. It's all been quiet on the Jag front the last week, or maybe I'm just not tuned in. I don't know. I haven't seen anything too interesting to talk about. Oh, something I did get. I'll try to make this seeable. Is the Jag Bluetooth. I have that in the right way. Maybe that way. Oh yeah, there we go. Yeah, this is a really cool device. Cool. Well, I'm glad you got to play the games. Hopefully one day I'll finish it. I'm working on it slowly. I'm getting through it. And hopefully you'll be able to get a copy of that in your hands soon. So I'm excited to get it done, but apparently not excited to get it done fast. But working on it. I think there's a little bit of latency, and on their website, they say it depends mostly on the controller, which is interesting to me. I played. What did I play? I should have played Tempest 2000 to test it out because I've played that game enough that I would have noticed some latency if there was any. I had Power Drive Rally still plugged into my Jag, and so I played that for a while. Worked really good on that. What else? It seems like I tried something else. I think I was just messing around with this test suite program that we've been working on, and I didn't notice any noticeable latency. Of course, somebody who plays a lot more could probably notice something. It's at points sometimes it felt like there may have been a frame or two. It may have been a frame or two slower than usual, but again, I don't think average people are going to be able to tell. It's really. It's cool the way this is set up, but I'm also worried about long-term ability to set this up because right now he's using a website to configure this. What it does is it temporarily pairs with the device. You set up your buttons and then it rewrites the configuration on the device so it stays, which I think is awesome that it does that because basically I got a couple of these for multiplayer. I would like to do multiplayers on the stream. Eventually, I got to find somebody to do multiplayer with that's nearby. But what's cool about them is you can just configure them and they're done. And so I don't think I'll ever reconfigure these again. I don't see. There may be specific games that you could set up your buttons so if you're doing like speed runs or something like that. But I'm not interested in doing anything like that. So I'm pretty sure these are going to stay the way they are for now. There are a couple of games where there are problems assigning buttons. Yeah, they're on there. In fact, let me just bring that up really quick. I was looking at their post here anyways. Let's see. Do they have a link here? They don't have a link. Do they have a link here? There it is. We're going to take a look at it really quick. We'll do a little mini review here. I wasn't planning on this, but they are really cool devices. I had my one of my 8-bit DOE controllers hooked up. I didn't have my second one. Somebody has my second device, so I wasn't able to test multiplayer or two Bluetooth adapters at the same time. But they looked like they both powered up just fine. I assume they'll work just fine. What else? Oh, I tried hooking up my Atari VCS controller. That did not work. I tried switching between, because the Atari VCS has a PC mode on it. I tried switching to that, couldn't get it to recognize anything. I was thinking about, and I was thinking about jumping on the GitHub and saying, hey, how hard would it be to get Atari VCS support for the Jag Bluetooth adapter? And maybe I'll do that. So down here at the bottom, it's fairly easy to set up. It looks a little complicated, but it's pretty easy to set up. Where is it? Known quirks. Yeah, Atari carts, there's some mapping issues. It looks like there's some workarounds for this. Breakout. Looks like there's still mapping issues, and I haven't actually checked to see if there's a firmware update. So maybe I will be doing this a couple more times. Missile Command 3D. Looks like there's some issues, but looks like there's an explanation, but no workaround for that yet. That's too bad. That's a fun game. Missed button mapping issues. There's a preset workaround to fix this. So it looks like they're just fixed. So looks like there's a few games. My guess is they haven't tested everything yet. So there could be some other issues. I actually found one issue, and it's really it's not my fault, and it's my fault because it's just naturally what the device does. So when you're reconfiguring it, you'll need to hit reset to get it to connect to the web application for some reason, and I don't know if this is just a problem with mine or if this is just normal. There's probably a video on their website that probably talks about this. I didn't go into depth, so take this with a grain of salt. This is a great device. I'm not trying to throw shade on it here or anything, but when I was configuring it, when you hit reset on it, it sends random button presses over the Jag, and so you have to have the Jag turned on in order to configure it. And I had PowerDrive Rally plugged in. Excuse me. I had PowerDrive Rally plugged in, and that copy of PowerDrive Rally is the copy I grew up with. And so and I showed this on stream, it had some high scores that my brothers had made back in the 90s. Well, I was on the title screen, and when I hit the reset button, it happened to trigger the EEPROM clear controller code, so to clear the high score table. And so I lost all those high scores. They're gone forever. And I sent them an email. I believe they are planning on putting a little warning or disclaimer on this page eventually. It may already be here. I'm not sure. Maybe it's under additional information. No. They came back and said that they were going to do that, and so hopefully they put that up there. And it could just be PowerDrive Rally. I haven't done any tests. I need to look. Yeah, ouch. Yeah, I was a bit disappointed. I wasn't angry or anything. It's just one of those things. It's fun to look at those high scores and as a reminder of those memories, and then those memories won't disappear until I'm older or something. So it's not a huge deal, and they're just high scores. It's all sentimental. It's not a big deal. But what I should have done before I sent the emails, I should have checked what the controller code is in PowerDrive Rally. I'm not sure what it is. It's probably like star pound an option or something. It seems like other games have a similar thing. But that's the issue. There may be other games, and I know some people are a little more attached to their high scores on these old games, and so hopefully they get a disclaimer up. What I would suggest is if you have one of these devices, just plug in a game, like a copy of a game that you don't care about the high scores, or it's a duplicate copy of a game that you like, and do the configuration there. You don't have to do it every time, thankfully. The configuration is baked into the device on some sort of flash memory, I assume, and so you won't have to do it very often. So. But XKS489, good to see you. No, and the Pro controller and the Jag controllers are nice too. The reason why I wanted to get these is I take this to family parties and other smaller retro events, just local community things, and a lot of people, they get turned off by the Jag controller. It's quite different than other controllers, and so what this is for is to kind of remove that barrier to entry for people, because especially young people, teenagers and stuff like that, they're going to be much more used to a PS3 or an Xbox 360 style controller, and so this gets rid of that barrier. That's why I got it. Also, I got it for streams, so I don't have to worry about as many wires. So as long as I don't notice any major latency issues, I'm planning on using these cool little devices in the future. So I've done my own research into building one of these over the years, and found it to be a lot more difficult, beyond my pay grade. And so it's really cool that Humble Bazooka is putting in the time to do these. If you're interested, just as another little note on this, excuse me. Is the way I set this up, the way I set up the number pad. I don't have it here. So my 8-bit DOE controller has 2 sticks down at the bottom, and so I set up the D-pad as the D-pad. And then I use the sticks, the top, up, down, left, right on both sticks as my number pad buttons. Everything except for 4 and 6. 4 and 6 are the shoulder buttons on the Pro controller, which I assign to the shoulder buttons, the bumpers on my 8-bit DOE controller. And you know, a lot of people might cringe at putting the number pad down on the sticks. I actually on what game? There was one game I was playing where I was using the number pad. Trevor McFerrin, the Crescent Galaxy. I actually really enjoyed that, to switch between the different special weapons that you do, the pickup weapons. I preferred that over the number pad. It was a lot easier to say, oh, give me 2, give me 3, give me 1. So that I think that's a plus personally. Sometimes because the number pad is in a grid, it's hard to know without playing a lot. Obviously, it's hard to know which button you're pressing without looking down at the controller, especially for beginners. That's going to be an issue. And so actually I was playing a little bit better on Crescent Galaxy than I would on a standard controller. So what would be really cool with this, in fact, I may put this on the GitHub, is have an option for, and they may already have this and I just didn't notice, for turbo buttons. So you can temporarily set up your fire button to be a turbo button, which might be a problem with menus. Well, in Crescent Galaxy, Trevor McFerrin, the Crescent Galaxy, it wouldn't be a problem because it's single button presses in the menu anyways. But that would be cool to have, or maybe have a toggle for that. So you can assign one button to toggle that on and off, and then obviously set up the turbo so you can shoot faster. Like a game like Raiden, that would be very nice in a game like Raiden. So, anyways, yeah. So I wasn't planning on talking about that, but yeah, they're really good devices. If you I would recommend this product if you do like your modern controller a little bit better. If you're fine with the Jag controllers, this probably isn't worth it for you, tell you the truth. Because the Jag controllers those games were made for those controllers. This is why a lot of people use original hardware and games to play these games still, is because modern, even reproduction controllers, sometimes have a hard time mimicking that original feel of that original hardware. And so I can completely understand if you're kind of against using modern hardware on games that were meant for older hardware. But I think in this case, you won't be disappointed if you are interested in using a modern controller. So anyways, don't worry, I plan on still using original controllers for most things. But again, this will help me share the Jag with some people. That's why I'm interested in it. Well, unless you guys have any other news items you want me to talk about, that may be it for news. Let's search Atari links here really quick. Sorrow. Oh yeah, that was a dungeon crawler that came out. This actually looked really interesting. Oh man, I was talking about doing a stream on this latest set of Lynx games. Maybe we'll do that next week, because those came out at the end of 2021. It's like 7 games, something like that. So, but hey, no problem, Ballad21. Thanks for joining me, and have a good day. Hopefully your job isn't too grinding, and yeah, hope it goes well. Again, thanks for stopping by. Oh man, I love Electro Cop. That's one of my favorite games on on the links, and it's really because of that title screen or the game music, the title screen music. I love that song. He kind of looks like almost like a Judge Dredd design, just a little bit, not a whole lot. Like that badge. Huh. Anyways, never noticed that before. I'm not seeing anything else. Nothing new. Got your usual Atari gamer posts. He posts a lot about the Atari links, and I've talked to him a few times. He's and I've actually done work for him. I've done some of the artwork for one of the jams a few years ago, and he's a great person to work with. I've definitely worth the follow. He's always got something interesting Atari links related to talk about. Hope I'll be back. Some merchant data recovery. Have fun, Ballad21. Data recovery. I have to do a little bit of that sometimes for people. Hard drive recovery. Just using what's the application that the average person uses? I think it's called PhotoRec, but it does all sorts of file recovery. Just layman file recovery, nothing too complicated. Yeah, anyways. Okay, I think we're done with news. Let's get programming. Oh yeah, we were going to talk about a little bit about the Matrix Screensaver that I have been working on. So this is basically what you saw before I messed it up with all the new code. And so I reverted back to my old code again and did some polishing on that code and added a bunch of options. So if we hit pause, and I may switch here, let me get some code on screen before we do this. Okay, so there's the drop color, so that's the head of the drop. So it's, in this case, it's white right now. The code color, that's the trail. I may switch that to trail color. Sorry about that. Keep hitting my microphone. Hey, good morning, Lee. Good to see you. And then the background color. And you can change these individually by holding down A, B, or C for red, green, or blue. Red, blue, or green. So if I hold that and then hitting left and right, so you'll see the head change to kind of a cyan there. And then if we turn the blue down, we'll get a very green, so that matches the green of the code color. And we can make it completely black if we wanted to. I'm not going to make it completely black. I'm going to add some red back in, get kind of a yellow going on. And you can do this for all three colors. Oh, whoops. Yeah, there we go. So we got orange. You can change how many drops it has dropping on screen. And that's just each individual piece of code going down. Turning this down will make it run just a little bit faster. And then code speed. This is the drop speed, and it's kind of an average. So some drops will go a little bit faster than others. And then the trail length, how many times it draws characters behind that drop head before it fades out. So I also have a burn-in option. Let me show you that. It actually leaves the last color burnt into the screen, which is kind of cool. It's especially cool with random turn on. And so let me turn that on really quick. And you can do random for all three of these colors. So it's kind of fun to do random on all three of these and see what combinations it comes up with. We'll watch this for just a second. And you'll see that the burn-in just turned off, because you'll see code as it comes down, it'll wipe away the previous burn-in. Oh, and I have a smooth fade between all the colors too. Got that all figured out. This is all figured out off stream. So I put about another 3 or 4 hours into this beyond the stream to get to this point. And so, but yeah, there it is. It's kind of fun to see the combinations it comes up with. I actually haven't put this on a CRT yet. I'm thinking about doing just a little vanity video of the Jag hooked up to my bigger CRT, just to show this running for like 10 or 15 minutes. Anyways, yeah. So there's that. Maybe I'll leave that running on the Jag. We're going to be using Virtual Jag today for coding. So let's get started. Coding. Okay. So the first thing we need to do here is we need to create a few files, because if you remember, we actually broke things out so we could do individual source files for each screensaver. So I'm going to go to cd change directory to screensavers, and we're going to make a new directory called, what should we call this? Should we just use Mystify? Should we use the same name, or should we come up with something clever that's Jag related? Meltify. Nothing's really melting though. May not be a good name. Maybe we should just call it Mystic. Use a discount version of the name. Yeah, let's call it Mystic for now. We may change that later. And then cd Mystic. We need to create two files. How am I naming? 64 Matrix Screensaver. So we're gonna touch Mystic underscore screensaver.h, and then touch Mystic screensaver.c. That touch command just creates a file in the directory. So if we list that now, you'll see that we have two files, Mystic Screensaver C and Mystic Screensaver H. So there's our source file. I have a little script here that I run that just reopens my project. I'll just reopen everything, and there they are. So, okay. I'm gonna try to be quick about this. I'm just gonna copy over code so I don't have to type it over again. Be a little bit faster. Like that. And yeah, just copy this really quick. Okay, we do need to change this at the beginning. Mystic. This is I don't know what this is called actually. I need to look this up. It's some sort of preprocessor, so when it compiles it, it knows that this is a unique source file and that it should compile it, even though there may be some duplicate includes. So it has something to do with that. I'm not entirely sure. And we need to Mystic like that. And we're going to create an initial function here, and we're going to, again, I'm going to look at the matrix and just see, looks like I didn't have a real naming convention there. So we're just going to call this Mystic Screensaver, like that. What did I pull in as parameters? Just my global settings. So we're going to do that here as well. Like that. Okay, we have our function set up, and we can. Oh, there's one more thing we need to do. We need to include this in our make file so it knows to actually build it. Mystic screensaver.c, just like that. I got one of the Bluetooth adapters the other day, but yet to try it out. Want to source a retro style Bluetooth controller in similar colors to Jag first, ideally. Perhaps 8-bit DOE. Yeah, I think 8-bit DOE has some darker controllers. You probably missed it, Lee. Earlier in the stream I was talking about hooking up my Atari VCS controller, which would be, there's something funny about that. I tried it out. I couldn't get it to work. I should take that back. There were, it seems like there were a few buttons that were registering, but they weren't correct. It seems like the Atari VCS controller is a beast in and of itself, the way it's set up, and so it'd probably take some effort on Humble Bazookas and or the developers on the GitHub to get that controller working. But that one kind of feels like the Jag. It has orange instead of red, but it is a dark controller, and it has the Atari logo on it, which is cool. So, but yeah, I have an 8-bit DOE controller as well, and and is it 8-bit do or 8-bit do? I'm not sure. I say do. But anyways, it works great. I was playing Trevor McFur for a few minutes and Power Drive Rally. I need to play Tempest 2000, and like I said earlier, if I played Tempest 2000, I think I would notice if there was more lag there. But in the two games I did test it on, it didn't seem like there was any latency at all. Again, I've heard that some people are a little more sensitive to that than other people, so I may not be sensitive to it. Okay, I think we have that set up. If we run make right now, yeah, it should just work. Make. Yeah, so we're good there. Okay, we have our source files set up. What I'm going to do is we're going to go update our menu so we can actually access it. You just got to remember where that is. Been away from this too long. Screensavers.h. So I have a screensaver. Yeah, right there. And we just need to add our new screensaver here, a reference to our header file anyways. Mystic Screensaver. And I don't know why I have my headphones on. I don't need them on today. I did an audio test this morning, so our audio should be fine. That's why I had them on. But okay, screensavers. And now we can actually call our screensaver. And we're just going to make it our second one here. If I can find my switch case, I assume it's a switch case. Yeah. So we're just going to copy this, create a new case. This is for case 2. And yeah, we just need to change this to Mystic Screensaver. So now we can actually go into that. Our menu options set up. Yeah, that's fine. So we can go to that. We need to change this to Mystic. Mystic, like that. Okay. Let's see if that worked. Let's do clear, make clean, and make virtual Jaguar. Oh, it didn't like something. Did I not save something? Let's see here. Mystic screen. Oh, I think. Yeah, I'm going to keep that capital, I think. I don't know if that's correct. They're technically not two different words, but it was capitalized here, and so I did not capitalize it somewhere, which probably right here. Screensaver. There we go. Now if we go to screensavers, there's Mystic, and it should just go back to our main menu, because it loops into that function and then just immediately leaves because there's nothing in it to do. Okay. So what I'm thinking, because we're essentially drawing a polygon, that's what we're going to be doing. And we'll look at the functions for drawing lines here soon. I first want to set up a structure. Well, maybe we should just draw a line. Let's do that. I've never done it before. Let me open up the source file if I can find it in the removers library. Source rmvlib. Oh, where does he have that? I think it's under, is it FB2D or screen? Let's open both of those. In fact, let's just open all these. So here's all the header files. Let's go check FB2D and just search for line. Oh, there's linear. Space. It's not in there. I'm pretty sure it's not in here. Matching points, compute bounding box, copy transform. Yeah, it's not in here. Must be under screen. Oh, it might be under render.h, which is his 3D stuff. Let's check here really quick. Set simple screen, clear screen, put pixel. Write a pixel to the specified position on the screen. So we can write a single pixel. That may be useful. So good to see that. Oh, and he has a structure for just a single pixel. Interesting. Let's see here. He has put pixel here and put pixels, right? A series of pixels. Oh, this is probably for his line drawing routine, is my guess. Maybe draw a horizontal line. So we can put multiple pixels if we want to. Oh, so that's what that's for. We can basically create an array of pixels. So we could draw sprites procedurally and then write those pixels right to the buffer if we wanted to. Now that's kind of cool. It's good to know that that's there. So we can draw horizontal lines, vertical lines, and we can just draw a line. And this is what we're interested in, because what it's doing is it's drawing a line from point 1 right here to point 2. And in the color that we want. Let's see here. What's that color? I assume that's just a color lookup table ID. We're going to find out. Let's see here. Draw a line onto the screen from point X and Y1 to X2 and Y2. Even if hardware clipping is enabled, it is recommended that X1, Y1, that the 2 points are inside the screen. So that's good to know too. Rotate screen and put the result in the target screen. Oh, he has a nice little rotation thing here to rotate graphics. We may use that in a future screensaver. We'll see. I wonder if that's just oh, this looks like its own function, because he has in the FB2D stuff that he did, which I assume is just older code. He has a rotation, and I believe he's using another CPU in the Jag for this, so it's supposedly faster. I believe. I'm just trying to remember where I read that. Maybe on his old website. I could be, again, grain of salt. It's been a long time since. I've only used this once, and it's for the BitJag logo screen in Oddball, which I don't think unless you have played it at the Portland Retro Gaming Expo, you haven't seen that, because I'm using this function and it doesn't work in Virtual Jaguar. It crashes Virtual Jaguar. So has some built-in copy protection that way, at least until Virtual Jaguar updates. Set matching points. Yeah. Anyways, so let's draw a screen or a line. Let's draw a line. This is pretty simple. I'm going to split my view here so I can see that line and draw it in here. I'm going to set up a while loop here so we can actually see it. Vsync. Just do a vertical sync so we can see something. And our line. So just invoke it. Oh, we should probably set a color in our color lookup table as well. Tom Regs and Clut1. And let's just make our second color, which is 1. Let's just make it white. Like that. Okay, and we're going to draw, let's draw from position 0, 0 to position 320 by 240. So one corner to one corner. And hopefully it's an 8-bit. Oh, there's a lot we have to do here actually to do this. In fact, how is it doing this? Even if, draw a line onto the screen. So this isn't using a screen buffer like what we were doing for the Matrix Screensaver. It's just drawing it straight to the display buffer. Gosh, is this actually... Oh, no. It's to the screen right here. I was overlooking that. So we do need to make a screen. Let's do that really quick. In fact, I'm going to try to keep this clean. I'm going to create a primary screen called Mystic Screen. Like that. And this is a pointer to that. And then we need a sprite. And we're going to just call that Mystic Sprite, because we have to turn that screen buffer into an actual sprite that is added to the screen. And we're not going to create a function for knitting this yet. We're just going to do it right here. So Mystic Screen equals new screen. And then we do alloc, simple screen, and I still don't have this memorized, so we're going to look at that here. It's just in here. Alloc, simple screen right there. And it's our depth, which is, our depth is 8 bits per pixel. I always have to remind myself of that. And 320 by 240. And our screen is Mystic Screen, like that. And then we do sprite of screen. That is right there. And we want it just at 0, 0. And it's Mystic Screen that it's going to be turning into a sprite. And then we attach the sprite to display at layer. I think I have this one memorized, and it has a good name because he gives you the order of parameters. So we give it the sprite. Oh, we need to tell it which sprite structure we're sending this to. So sprite equals Mystic Sprite. There, and then we tell it we want to attach the Mystic Sprite structure and to the display at layer 0. We're just putting it at the very bottom. Sorry about my throat. I have a frog in it today. I'm not sure what's going on. I don't feel congested or anything. It's just a little rough this morning. So that should, once we, here, let's draw our line before we turn it into a sprite. I don't think that matters because it's just a buffer. Mystic Screen. But let's draw it to our screen like that. We should be good to go. We should see something on screen. Let's take a look. Oh, on function. Oh, I missed a semicolon somewhere, or I put a semicolon. Expected 23. What? Oh. Save this. That'll help. Screensaver Mystic. Oh, 5. Line 5, not 23. There we go. What is it complaining about? Oh, I forgot an equal sign. There we go. Error D undeclared. I thought I had. How am I doing it? Am I bringing in the display? I thought it was a common asset. Because I'm pretty sure my display structure is just... Oh, I have it under settings. So this just needs to be S. So this is just, it's in my global settings that I'm passing into this function. The display it's going to be attaching the sprite to is inside that structure. So, okay, attach sprite to, oh, I think it's to display. To display. There we go. Okay, did it draw a line? Whoa. Oh, I need to run a, there's still garbage. So when I allocated this screen, it doesn't clear the memory, so it's all zeros. So all those dots you saw was just garbage memory, random values, and it was all white or gray, I think, because we assigned this in the color lookup table. Usually it's all sorts of different colors if you have a full palette filled out, but in this case we only have a few colors. So let's do a clear screen. Screen, Mystic Screen. Oh, wrong one. Screen. Like that. And that'll give us an all black screen. I'm a little concerned our line isn't going to work though. We may be up a creek here if I can't even draw a line. That's strange. What am I doing wrong? Mystic Screen equals new screen. We need that. Alloc simple screen depth 320 by 240. That should be fine. Mystic Screen. And we clear it. Drawing our line. Let's take a look at that really quick. We have our screen, the first point, second point, and then the color, which I assume is, he doesn't say anything here, so I'm not, maybe it's further up. Let's go take a look. Color. Nope. Yeah, there's no, he doesn't say what this is, what this is supposed to be. Well, it's definitely not an 8-bit color value that he wants. I think he's just looking for which color in the lookup table should the line be drawn with, which would make sense to me. That's the obvious answer here. So, but there's no notes on it for sure. Let's just see if those small changes did anything different. Oops. There we go. It's kind of should be white, but oh, whoops, this should be 1. There we go. Let's make sure it does what we expect it to do. There we go. Got it. We have a line. Awesome. We're almost to full 3D graphics on the Jag. We got one line for one side of one polygon. Yeah, we're almost there. We'll see. We'll be drawing 4 lines per. We'll be drawing 4 lines for. I was looking at the Mystify Screensaver yesterday, and it seems like in Windows 95, I believe, is when it was introduced. All you had is you could set 2 colors, or you could have those colors be random for the 2 different shapes, and then you could tell it how many lines to draw. And so we may do just that. Again, I haven't thought through this entirely, so we're in dangerous territory here. But we did see a line today. That was a lot better than the Matrix Screensaver a few weeks ago. You guys didn't hardly see anything except for code, and so I'm trying to make sure there's some Jag stuff you're going to see today. But anyways, okay, so we have our line. We can draw a line, which is awesome. We're going to get rid of that because we don't need it. And we're going to leave this here. I don't think we need to set up an init function for these few lines because we're only running it once. So, but we do need to make sure that this stuff clears out appropriately when we leave this screensaver, so we don't build up stuff in memory and cause a crash because we filled up memory. And that's pretty simple. The first thing we do is detach sprite from display. I'm pretty sure that's the name of that function. And we detach our mystic sprite like that. And then we have to free that structure, that mystic sprite structure. Because when we run the sprite of screen, it actually allocates memory for this structure. And so we just have to make sure we run free when this free function when we're done with that. This is a typical function in C. It's not unique to the removers library. So once that's freed, we can go in and clear up our screen structure now, which is a little tricky, and it took me a long time to learn this. It was causing all sorts of crashes when I was first starting on the Jag. Because he doesn't have any nice function for this. You kind of have to know how C works, and so I've learned that over time. So the first thing you do, kind of rambling here, is we don't free the structure, the main structure first. We have to free the data member of that structure, and that data member is the actual pixel buffer inside that structure. We have to free that first. And then we can free the structure that data is embedded in. And that's it. That should clear things up. We should be able to run this function for the rest of time or until the Jaguar explodes, and it should never crash. So, hopefully. you're better at coding than I am. I can only make Jag hardware. Well, sometimes I wish I could do that. So I really am a novice coder. This stuff. This is so coding on the Jag is the first serious coding I've done. Before that, it was just front end coding like HTML and CSS, which isn't. It's code. Like, don't get me wrong. I don't want to throw shade on that, but C code is a whole other beast. You have to be. There's a whole other level of awareness in what you're writing as code, and there's always something I'm missing. So basically what I'm saying is I don't have a talent for this. It's really just brute force learning, which is, for most people, that's what learning new things is all about. And so I have seen a huge improvement over the last 5 years. I basically started from zero, and now I can make some games, which is awesome. What I really don't, and this is kind of stupid complaining here, but now that I know how to do a lot more than I used to, I have a lot of ideas I would like to realize and no time to do it, which is kind of unfortunate. But it is nice that I do have this skill now. I think at this point I could probably monetize it a little bit if I wanted to, but brute force is probably the best way. Yeah, I kind of wish I had. I've never been a huge reader. Like, I love reading, but there's things that take higher priority. I kind of wish I had just sat down with a C manual and gone through some beginner tutorials with that before jumping in to C code on the Jag, because I was just learning from the examples that Seb had, and a lot of that wasn't commented a lot, and so I thought I was doing things right, or doing enough. Really, that's the way to put it. I thought I was doing enough, and realizing that there were some important things about memory management that I didn't know, just basic, like, fundamentals for C code. And so I've learned those over time, the hard way. And what's nice about that is I learn it well. When you learn something the hard way, you usually learn it well. You don't forget it. And so, anyways, okay. So we got that all cleaned up. Now back to what I originally wanted to do once we got the files set up. We're going to create a structure here, or a definition for a structure. Type def. If I can learn to spell, type def struct. So a custom structure, and we're just going to call this, we're going to call it vertex. The setup you have for changing code and recompiling quickly is something that the original devs never had. Yeah, and that speeds things up considerably. Like, this is, so I'm in Kubuntu. It's my operating system of choice right now, and their default text editor, it's not an amazing IDE for coding, but it's pretty good. It works pretty well. I like how you can just bring a terminal up and it's already navigated to the path that you're working out of, and so you can just run all your commands right there. I love the split screen stuff. That's really useful. It's a nice program. I know other programmers, they use other stuff, but I'm pretty comfortable here. I don't have to install any other applications. When I reset my operating system, it's just all there, ready to go. So this is what I've gotten comfortable with. It works nice. But yeah, you're right. I'm sure a lot of programmers back in the day, they were running out of DOS most of the time. There may have been a few that were running Windows 3.1, but they're probably few and far between. That's my guess. Most of them are either on an ST still. I imagine groups like the group that did Zool, they may have been on Amigas doing stuff. But I imagine there were a lot of people on Falcons and STs and DOS machines primarily. So other people might be able to confirm that. I actually haven't looked into that. That's what I've just assumed based on the documentation that Atari provided. It seemed like most of it was designed for DOS. Okay, so we're going to make a structure here, and we're going to create a primary point. Is that what I want to call it? Is there something more clever I could call this? So what I'm thinking, so on Mystify, you have your primary line, and then you duplicate that line somehow behind it to create that trail. And what I'm thinking is what we'll do, and I have no idea if this is going to be fast. This could be just really slow. The way I'm thinking, we're going to find out. Is we're going to create a primary point. We're going to draw our first line, but we're also going to keep track of the previous few lines. And that's going to, and eventually we'll create an option that'll allow us to change that length, like in the original screensaver. I'm just wondering if I should build that in. We're going to have to do some manual memory allocation here in order to accommodate that. For do I want to do that up front? Just so we can do things quicker. I wonder if I can do it. Can I do it here? No, I don't think I can do it here. I have to manually allocate that. Okay, so we're going to create a primary point. Or do I want to bake it all in? To keep this as simple as possible. Yeah. So we need this to be a pointer. No, we can, well, it's essentially the same thing. Yeah, let's make it an array, just so anybody who's familiar with arrays, they can see that here in the code. It's essentially the same thing as creating a pointer when you create an array. Or functionally, it's the same. And we're going to call this point point positions. So and this will be XY. It will be XY positions times how many lines we're drawing. And this may be all we need, actually, now that I'm thinking about it. We'll be making a function that just goes through each one of these and draws them. Yeah, let's do that. That'll work. And then we're going to create a function, vertex, of type vertex. And it will be returning vertex init. It'll be returning a structure that's been set up, the memory for that structure. So pretty simple. This is a common thing that I do when I'm working with structures. And we do need to pass in how many points or how many lines, because that's going to determine how many XY coordinates we need to keep track of. Let's see here. Just thinking through what we might want to do. So the Mystify Screensaver, I believe each shape only has 4 points that it's working with, and I think that's hard-coded. They can't do more than that. We could code this so we could do more points. I just don't know if that will actually look good at the end of the day. I mean, there's probably a reason why they only picked 4 points for that screensaver, because it looks good. I'm assuming. So maybe we'll just stick with this. I'm debating whether to create another structure that will be nesting these vertexes in for the lines, or the shape that contains the lines. Let's just do this right now. We're going to create, we'll take smaller steps here. We're just going to create a square here soon. Yeah, we're going to create a square and draw that to the screen. So this is going to work. And we're actually going to do points on this. We're actually creating a shape here. So this is shape. Vertex. Vertex count. Amount. There's probably better words for this. So vertex init, shape init, shape. We are creating a shape that will have 4 points in it, and these are the positions for those points. And we're not going to, in the init structure, we're not going to define where those points are. We're just going to initialize them all at 0. And then you'll have to manually go through and set those points. And we may create just a simple function to set those easily. Okay, let's build our first function here. We're just going to do it in the same source file outside of our main function. This is shape init int vertex amount, like that. And let's build it. So what we do is I'm just going to create a structure inside this function that will be returning back to our shape structure once we get to that point. Equals malloc. In fact, this whole init is really just one line. So this may be a waste of time doing. Well, it may not. We may be changing this function later on, and so it's good that we're doing a function up front. And we do size of shape. So what it's doing is it's just saying you need to allocate the size of this. What's tricky about this is we don't know how many we're doing here yet until this is passed through. And so it's an integer, and so we have to do some maths here. It's an integer, so it's going to be vertex amount times by size of an integer, which I don't think we need to put this in because I think it defaults to that, but I like doing it just so I know it's the right size. And if we want to save memory, I'm not worried about optimizing for memory here, but if we wanted to optimize, we'd make this a smaller value, like an unsigned 8-bit integer or something. And so typing this here gives us that flexibility in the future. But we also need to times this by how many values we'll be storing. And so for each point, we'll be storing a x, y value. Yeah, so just 2 values. So we just need to times it by 2. Hope this works. we can do some debug things here and see if it actually works. So size of shape. In fact, we can get rid of this because there's nothing else in here right now. We will need to rework this if we add any other members to this. Is there any advantage? Oh, there are some other things we need to do. We need a CLUT ID. CLUT ID, so the color that the shape is going, the palette ID it's going to look to derive its color from. We will need that. And this is actually a uint 8_t. It's an unsigned 8-bit integer. It's just 0 to 255. So we do need this, and we're going to be adding, because this is undefined right now, how big this is, we have to add that to whatever the size of this is. So vertex, that's vertex amount, and we're going to do some math here. Vertex amount times 2 for the xy values for each vertex, and then that's times by the size of that variable, or that of that type, which is integer. That should be it. We should be good to go. We just need one more parentheses there. Good. Return, and then we return that structure to whatever structure is in our actual main loop. Yeah, should be good. Let's see if we can draw a square. That should be good. Let's do a test. We can do a test. So let me turn on our debug console. Where are you? I think it's just right here. Yep. like that. Copy this so I don't have to type it out again. And just in here, we're going to print, once we get this set up. Actually, we do need to set this up first. So let's create a structure here. This is a shape, and this is our, we're just going to call this shape 1. This is going to change in the future. Shape 1, and so shape 1 equals shape init. Yeah, shape init, and we're just going to do 1 vertex for now, and then we'll test it with 4 and do all that. Oh, we need to actually set our values. So s, we're going to do a for loop. I equals 0, I doesn't equal vertex text amount times 2, because there's 2 values for each vertex. I'm going to wrap that in parentheses. I don't think I have to do that, but I'm going to. I plus plus, and we go through all those values, and we assign, we're just going to assign S. Yeah, I'm just thinking about how I'm organizing these. It isn't a 2-dimensional array, so it's functionally a 2-dimensional array, but in C we're using a 1-dimensional array, and the second dimension is every 2 values is a position. And so I'm writing a 2-dimensional array. Instead of 2 values go down a line, 2 values go down a line, I'm just doing 2 values comma 2 values comma. Essentially I'm just doing it horizontally rather than vertically. It simplifies the code if you do it that way. The reason why they, at least in my opinion, that they have the ability to do 2-dimensional arrays visually in C code is it's easier to read that code. Whereas if you do it on a 1-dimension, but it's functionally 2-dimensional, it simplifies your code a little bit, but it makes it harder to read or to comprehend if you aren't comfortable or familiar with doing it that way. There's a reason why I do this. There's tile maps. It simplifies tile map code a little bit if you can think of your square that is your tile map. So you have numbers that represent different tiles. If you can think of that in a horizontal line instead, that those values are in a horizontal line, and you just have an offset for each row, it just makes the code a little bit easier or shorter to write. I shouldn't say simpler, I should say shorter code, less code, if I remember correctly. Okay, and then we just do that, equals 0. There we go, and it's just assigning each one of those points to 0. And so up here, what we can do, we do a for. There is another thing I need in here. I'm going to put vertex count. And this is just going to keep track of how many vertexes we have in that shape, so we can use this value for our for loops easier. And I just need to assign that, and I'm going to assign it. Oh, we do need to pass in int. No, our vertex amount is going to be our first one, and then we're going to do, in fact, I'm going to put this down. No, down here. Nah, we'll leave it up there. And so int 8_t. This is clut ID, and then we just need to pass in those two. We're going to set our clut ID here really quick by clut ID equals clut ID, like that, and then s vertex count, that's what we called it, right, equals vertex amount. The value, we're just setting this to be in our inside of our structure now, so we can keep track of that number. There we go. And then, heck, we'll just do this. That's fine. I don't mind doing that little bit of math in that for loop. It isn't taking too much time to do that. Okay, we should have everything there. Pretty sure. Should be good to go. Yeah. We just need to change this now. So this is going to be clut ID2, like that. And we do need to update our declaration in our header file right here so it matches. It will complain about that if we don't. And then in our for loop, back to here, we're going to need to add some I variables here soon. I equals 0, and as long as I does not equal, the reason why we sidetracked was to get this vertex count, or what's it called? Yeah, it's called count inside the structure. It's called count, like that. And we're gonna just print a few times a integer with a comma after it, so we know which each value is, and we send it. Oh, this isn't S1, it's shape1. We use S inside of our init function. Yeah, but out here we're going to use names that we recognize, or something that's a little more readable. So shape1, and this shouldn't be point position, this should be vertex positions. Vertex positions, just to keep our naming consistent. There we go. So vertex position. Yeah, and it returns that according each one of those values. It'll send back in that for loop and print it to our debug console. Yeah, we should be good there. That's fine. We do need a I variable there, and we need it in here too. Okay. Let's run a make command, because I'm sure there's something I'm missing. Shape has no member called vertex position. Oh, vertex positions. There we go. There's that one. You know what? I'm gonna leave that plural. That's fine. 42 on C. 42 shape. My pointer is on the wrong side. Matrix Screensaver. Set but not used. That's fine. 45 vertex amount. It's right there. Did I not? Oh, I didn't spell it right. There we go. All typos everywhere. 48 error shape has no, vertex positions. There we go. There we go. So I don't think, oh yeah, we were printing, so we only got one value that is not right. It should be printing at least two values. Oh. Oh, we have to do that same math up here. Because there's two positions for each value, right? So we got to do a times 2, like that. And maybe we will put just that value inside the function. Just so we have it. We don't have to do that math every time. It'll save us a cycle, I think. It's not a huge deal that I have to do that math over and over again. There we go, 2 values. So that's working. Let's make sure it's working by just putting in a random, like 45. So each value is going to be set to 45. So we should see 45. Yeah, okay, cool. Let's do a bunch of them. So up here, instead of doing just 1, let's do 4, which is what we're going to end up doing. So we should see 8 values that all say 45. Yep, we're good. We got it. Okay, so that seems to be allocating correctly. Should be fine there. Let's write another quick function here. It's just going to be of type void, and its shape, it's going to be called free shape. And this is just to clean up our memory before we leave our screensaver. And we just take shape S like that. And yeah, that should be fine. Yeah. Oh, wait, no, that isn't fine. I learned this the other day. It needs to be type shape. And we're just going to set it equal, because what it's going to do is it's going to return a... Oh, does that work? I could just do this manually too. There was something I was running into a problem with freeing my custom structures. Just trying to remember what I ran into before. I can't remember. Let's try this. We can do a test on this too to see if it works. Let's go back to void, and just return the shape. First, is this gonna work? Yeah, this should work. Shape S, and then we don't need this return. And we just do free. We have to free. Oh no. Oh, we don't need this. We don't need, at least right now, we don't need this function. In fact, I don't think we're gonna need it. All we need to do is down here we go free shape 1. That should work. There's nothing special. If we had other structures in here, I'd write a structure, a custom, not a structure, a custom function to free that. But this should work just fine. Yeah, so we're good to go. We have a shape. We need to set the coordinates of that shape really quick. Let's just do that manually. So shape 1, because we wanted to draw a square, correct? That is what we wanted to do. Pretty sure. This is vertex positions. So the first vertex, X and Y positions. I'm just going to copy this. So this is the first vertex. We're going to do at 100 on the X, 100 on the Y. And then our second vertex, and I'm going to space these out so it's visually easier for the audience, for you guys, to see that. Our second one, and okay, so this is another thing we have to decide. We have to decide in what order we're drawing those vertexes. And so what I'm going to do is it's going to start top left and go clockwise around. So I know that's important when drawing polygons. I don't know why that's important, but it is important. I read it somewhere. So if what I read is true, then it's important. So this is going to be at 120 on the X and the same Y. Again, we're drawing a square. And then our third point is the bottom right corner. So it's going to be at 120X and 120Y. And got to change that to 4 and 5. And then our last point is below the first point, but aligned on the X, so it's 100 and down below at 120. And these are pixel values, so it's pixel 100 and pixel 120. 6 and 7. So there's our our 4 vertices. So 1 and our X and Y values for each vertice, like that. So those are set, and now we need to create a function that goes through each one of those vertices and draws a line between them. Tricky. I haven't thought about this at all yet, so. Well, let's do the first thing. I know what we need to do first is write a declaration for our function. And this is, we're just going to call it draw shape. And we need to pass in our shape, a pointer to it. Oh, we're just declaring here, and we are defining in our C file right here, like that. Okay, so we have our shape. What do we do with it? Well, we're definitely going to be doing a for loop to go through all the vertices. So for, and we're actually going to need 2 of these. And vertex. Okay, I'm going to be a little more verbose for these. This is vertex ID, and this is X or Y coordinates. So I'm just going to do coordinate. Is that how you spell it? Automatic spell check. Yay, I got it right. Cool, I got it right. Okay, coordinate equals 0. And this will just be toggling between 0 and 1 for X and Y. Pretty simple. So for vertex ID equals 0. So we always start at the first vertex, equals 0. And as long as vertex ID doesn't equal our vertex count, so S vertex, so the structure, the count that we're keeping track of. That's how we added that to the structure, is for this loop. Vertex count, we go and we just go through all the vertexes. So vertex ID, I spelled it right, plus plus. So we hit each vertex, and then we need to go, oh wait. I don't think we need coordinate. Wait a second. Oh yeah. This works. And I think we need to do one less. I've never done this before, so this is definitely a learning experience for me. Because so we have our first point, we need to get the coordinates for both the first point and the second point. And so we draw, so we can draw that line. And then we draw the next line, and then the next line, let's see here, 0, 0 to 1, 1, 1 to 2, 2 to 3. Then 3 to 1. We have to loop back around. That's probably why the direction matters. So that the last loop that we do in our for loop is important. So 3 to 4. Or 3 to back to 1. Or 3 back to 0. Sorry, not 1. There we go. Okay, I think I can do this. I think I can. So I don't think we need this. Because we're just going to each vertex and then we're just looking at the next vertex except for the last one. So we need to do a check for that. If vertex ID is equal to vertex ID minus 1, so our last, that's when we do our loop back around to the first one. Else, for all the other points, we just look at the next vertex to draw it. And we are going to set up some other variables here. So we're going to do int x1, 0, x1, and that'll be y1, x2, y2. So y1, I should just use I should just use 2. I should just use some arrays. Let's use some arrays. Let's do vertex. First, I'm going to use point for this. First point. First point positions. And I'm just going to initialize this just to be safe. And then second point positions. because what we're going to do is we're going to update these two arrays every time we loop, so we get our points, and then we'll draw our line once those points are filled in. So we only have to run that line function once, because we've filled in these values, we know what our points are, and then we just tell it to draw. Okay, so we know what our first point is. So first point, yeah, we're just filling this stuff in now. First point, X position equals our shape, vertex positions, I guess I could do some math. We're going to create a selected vertex equals, this just gives us the offset for our the vertex that we're selecting inside of our vertex positions array inside of our shape. So remember how I was talking how our array is just a line of values? This variable here that I'm making just pre-calculates our offset in that, so we're selecting the right one that we're pulling the values for. So vertex ID times 2. Simple. And we'll run that each time we do the loop because we want to select the next vertex. Yeah, and then we just do selected vertex, vertex position, selected vertex, and I'm going to do a +0 because that's our X coordinate that we're selecting there. And then for our Y coordinate for the first point of our line, we grab the second one, like that. Or, sorry, the Y value. Because we go to the position value of the vertex that we want, and it's XY, and so we do just +1 to get our Y value. That should work. And I screwed up there too. And then we get our second point. And this is simple too, because we know our second point is, so if we get our offset there, in fact, I can just do this. Let's just do this. No, actually that doesn't work. Well, we can do it. We can do it here. And we're going to do select. This needs to be selected. Past tense. There we go. Update these really quick. Selected vertex, and what's a better word? I'm thinking following vertex. Or, see, I think I need to, first point. We're just going to call this first point. Or no. Okay. This is selected vertex. Yeah, and following vertex. This isn't the best verbiage to use for this, but hopefully it makes sense. We're just, this first variable is selecting the vertex that is going to be our first point, and then this will be the offset for the second point, which I need to update. Second point position, second point position, and the following vertex, and we're going to set this to 0 because we need to update this in here in our if statement. So if following vertex equals, here it will remain 0. So maybe I don't need to worry about this. I'm going to leave it there just in case we do need to update here. But here, it's always going to be an offset. It's going to be at selected vertex +2. It'll always be after the Y value of our first selected vertex, which gives us the X value for the following vertex, like that. And then now we can just take this and do this, just like that. Okay. In fact, I'm going to just compress this code because it's simple to read. Like that. And then, so what's going to happen is it's going to go all the way to vertex 4, our last vertex, and it needs to know that it needs to draw to the first vertex. So we're going to take these same values here, see if the logic just works out. This is correct. This is our first point, so we don't need to change that. In fact, because of that, because we don't need to change that, we can move this out of our if statements, because it's really the following, the second point we have to worry about. So we don't need to duplicate that code. We just need to do it once. So the following vertex, we just need to point it back, so we can just get rid of this right here, like that. And it's just going to select the very first vertex in our array and say paint back or draw the last line to that point, because that's the second point. Yeah, that should be it. I'm probably missing something. Vertex. So we don't need to set this. In fact, we can just move this. We can just do this, and you know what I should do? I shouldn't even do this. This was a waste of time. That following vertex garbage. We just need to do a +2, +3 on our selected vertex, like that. There we go. First and second positions. Our array values look correct. Yeah, that should be done. This, and then after we run that for loop, what we do is we draw. We have to draw it each time we loop. So, what was it? Line, and it was Mystic screen that we're drawing to at, and then we just plug in our first point, X and Y, in this case 0 and 1, and our second point position, X, and second point position, Y, and it wanted a color if I remember correctly, so we just pull that from our shape, and we have a member inside of our shape structure called Collet ID, and that's the color that we're going to be using, or that's the palette ID that we're painting to the buffer, so we're selecting the color that we want. Something like that. Hope that made sense. Yeah, we should be good. Draw shape. That's all hunky-dory. We should be fine. Right there. So now, in our C file, we do need to change this back to 0, and we need to manually set our vertex positions. Oh, I'm doing it here. I already did that. Okay, so we're good there. We got that box. Now we just draw shape, and we pass shape 1. That should draw our shape. No reason why it shouldn't. I'm going to turn off our debug console. No reason that I know of. I'm sure there's something I'm missing. I haven't run a make command yet, so there's probably some syntax errors. So let's run that now. Make. Warning, unused variable I. Where is that? Oh, it's out here. Yeah, so I can get rid of that for now. We'll probably be typing that back in later. 72. What is it looking for? 72. Error, expected comma or semicolon before int. 72. Oh, I just missed these. There we go. 79, expected parentheses. 79, expected parentheses. Oh, yeah, missing a parentheses there. Vertex ID equals, yeah, that should be fine. Double checking my logic there. Hey, it made something. Let's go make sure there aren't any other warnings. in the Mystic. Warning, implicit declaration of Mystic. Why? That should be correct. Mystic. Oh, I didn't declare my main function in my header file. That's why. Let's just do that up here really quick. I usually like to keep the functions bunched up in my header file. Let's run that again. That should have gotten rid of make clean. Make that warning. That warning won't break anything. Gosh, clear. Make clean. Make. Yeah, got rid of that. Okay, cool. Let's see if our line is drawn. It's all wizardry to me. Yeah, sometimes I feel like a wizard, and the reason why I feel like a wizard sometimes is wizards are often portrayed in myths and stuff like that as a little bit crazy, and so you'll do this cool thing in code, and then a week later you'll forget how you did it. And so thankfully it's written down, you know. And so sometimes I feel crazy because it's like it wasn't as hard. Like when I figured it out, it's one of those, oh, that wasn't as hard as I thought it would be, but then a week later you forget about it and you have to go back to your code and relearn it. And so anyways, that's why I consider it wizardry. Don't think it's because I'm that intelligent. Really, at the end of the day, it's that I forget things. I forget things that are really cool that I did do, and so it becomes almost mythical in my head that I actually did it because I don't remember how I did it. Okay, let's do this. Let's see if it actually drew our square. It'd be cool if we got this the first time. Oh my goodness, it almost worked. It's that last loop around. There's something that we missed. That's cool, and our ID is incorrect for some reason. Did I put the right number? Let's see here. Pretty sure I set that up correct. S-clut ID, yeah. Did I set it right or correctly up here? Oh, yeah, I got it wrong there. Whoops. Save. There we go. There we go, it's white. Okay, so we got to figure out why it's drawing up at 0. I shouldn't be doing that. So if vertex ID equals vertex ID minus 1, which in this case will be 3, our last vertex ID, it should just be writing the x and y position of our first vertex. Wonder why that isn't working. It's definitely there because it's drawing the top line. What am I missing? I could hack this and just store it for later. I don't want to do that though. There's just a little piece of logic here that's not correct. Vertex count minus 1. This shouldn't change anything. It should be the same value. Oh no, that fixed it. There was something. Let's see here. Oh, because it was hitting 3. Okay, yeah. So what was wrong is it would hit 3, but it was actually 3 minus 1, which is the second vertex. I didn't want that. I wanted the max vertex I could count up to minus 1. I needed. Okay, we got it working. We got a square. Let's go look at it again. Sorry, I kind of escaped from that really quickly. Let's check it out. Oh, look at that square. Isn't that awesome? We got a square. We can draw squares. We can draw triangles. In fact, let's draw a triangle really quick. That's really easy. All we do is we make it, because a triangle is 3 points, right? And we just wipe out this last one. It'll be oriented weird, but it will be a triangle. There it is. There's a triangle. Easy. Easy, right? Easy. Not really, I guess. But that happened a lot quicker than I thought it would. What time is it? 7:40. Man, we might be able to get a line moving here. What is the quickest way we could do this? We're drawing that. I'm not going to worry about our other lines right now. I just want to get this bouncing on the screen. We are going to need a new function, so let's do that. Void move shape. And we bring in our shape. Pointer. Pointer reference, I think that's what that's called. And we are defining it there, but we need to declare it in our header file right there. The reason why I'm bringing in the shape here is because we're going to have multiple shapes in our main loop, and so we'll need a for loop to just iterate over all those. And so we may create a function that just does that for us. We'll see. But yeah, we just need to move the shape now. So I don't have in our shape structure, I don't have vectors set up for that. So what we could do is we could do int. Oh, can I do this? Oh, we may have a problem here. Let me think. I think there's a caveat to doing an undefined size for an array at the end of a structure. You can't do two of them. There may be a restriction on that, and that's okay because I can still just work with this one. What we could do is change this to vertex data, and then basically we create four. In fact, that's what I'm going to do. It's simple. It's simpler this way. I'm just going to call this vertex data, and let me define that for you guys to see. So for each vertex, we're going to have 4 points of data. The first one is our x position, our y position, and then our x vector and our y vector. And you know we're probably going to need 5 at some point, or 6 per vertex. We have our vector, and then we'll have a speed for each vector. Let's just do that while we're here. So x speed and y speed. And the reason why this is simpler is we just need to know, so right now our offset for each vertex is 2, because before we were just storing the x and y value. Now it's going to be 6. And so we just have to change our name and our offsets, which isn't difficult because we know what that is. So these will change. So instead of 0 and 1, it's every 6 values. So 0 to 5 is our vertex, and then 0 to 5, then 6 to 11. And I always have to, let's see here, it would be 24 would be the max, but it would be 12 or 18, 19, 18, let me count on my fingers, 18, 19, 20, 21, 22, 23. That's correct, because it's 0 to 23, because we're counting from 0, not 1. It's 24 values, but because we're counting from 0, it's 0 to 23. So, okay. And we're not going to do anything beyond this except for change things and then run our program again to make sure all my offsets and everything are correct. Yeah, and we're going to need to write a function that fills in this data for us. For when we init everything. When we init all those values for the shape, because it's a lot of values to type in manually. We can do that here for testing purposes. And maybe we'll do that because I'm running out of time. And what we'll do is I'll manually do some vectors and some speeds just for this demonstration, and then tomorrow we'll flesh that all out a little bit. Okay, so I need to change some things here. It isn't vertex positions anymore. So I gotta change everywhere that's at. And then this needs to change too, because instead of 2 values, we are now storing 6 values in that array per vertex. So 6 and 6, like that. So that memory should be properly allocated, and our selected vertex is every 6 points of data. And that still wraps around correctly. That's good. And this one is different. This needs to be plus 6 and plus 7. Like that. Should be it. Nope, didn't like something. Oh, I haven't saved my header file. There we go. It still doesn't like that. Shape has no member called vertex position. Oh, I still have some right there. Duh. Oh yeah, we gotta redo. Oh, we already redid those positions, so fine. That is fine. There we go. And something's wrong. I just don't have my offsets correct. Got the first one right and the last one right, which is interesting. So that means these aren't correct. This offset is not correct. So 0, second point. Oh, that's fine. That should be fine. Yeah, 6 and 7. 120. Why didn't that work? Oh, the second point is correct. 6, 7, then 6, 7, 8, 9, 10, 11. 12, 13, 12, 13, 14, 15, 16, 17, 18. Those should be correct. Okay. This is why we're going to be baking this in. Yeah, there we go. This is why we're going to be making a function that fills in all these values for us. We'll just put in a bunch of parameters and it'll just automatically assign these to the correct values. We will be doing a function for that here eventually. Okay. We may not be able to do this in time because there's quite a bit of work. Just trying to think of the quickest way we can do this. Let's see here. For our first vertex, so our first vector, our x vector, I'm just gonna put in some random values here. We'll make that -1. And our second vector will be 0 for now. Or no, we'll not do any of those. We won't do anything on a 0 vector right now because we're not going to do anything with speed except for we're just going to set it to 1. The speed is going to be 16.16 or 16 point precision, where we just take so we take 16 bits, or we take a 32-bit value, which is an integer, and we cut that in half, and these 16 bits are the decimal and these 16 bits are the integer. That way we can create some more nuanced motion. Later on, we're not doing that today because I need I'm not very good at vector math, and so I have to relearn it every time. And so tomorrow we're going to be relearning some things to do that. But I can do some integer movement fairly easy here, I believe. So that's what we're going to do for today. And I'm just going to set the speeds both to 1. Okay. That. I'm going to change these 8, 9, 10, 11. And again, manually inputting all this data really is kind of a waste of time. I will have a function tomorrow. We'll write a function that does these lines of codes basically with one line of code. so I don't have to keep track of all these numbers and update all these numbers. It just takes too much time. But for today, we're just going to put in some default values and then get things moving here, hopefully before we're finished. We don't want these all to be the same to begin with. So let's make this 1, 1, 1, negative 1, and 1, negative 1, like that. There we go. And they're all going to have the same speed. Yeah, they're all going to have the same speed. So we're going to need to write a move shape function, which we already have declared, and we've started our definition. And we bring in that shape for we got to do a similar thing as up here, vertex ID. For vertex ID equals 0 and does not equal s vertex count, and vertex ID plus plus, like that. So we're going to go through each vertex and we're going to move it according to its vector and its speed. That was weird. My screen just flickered on and off. Not sure why I did that. Okay. This should be pretty simple. And we're updating the position. So let's give this a try really quick. And then we'll redraw our shape. Yeah, we go through, we update all the positions, and then we draw the shape. Update our positions, draw the shape. Yeah, that's all we need to do, pretty sure. Okay, so vertex data, and we need to do our selected vertex, kind of like what we did before, which is here. Our selected vertex. Vertex data, selected vertex plus 0, so our x position, we're going to be updating the x position, equals same thing, but this time we're selecting the vector, which is 0, 1, 2. So position 2 in our data, our group of data for that vertex. So it's the vector, and we're just going to do times speed. It's probably the other way. It's speed times vector. We should flip that around. That's fine. We'll just copy this by x speed, which is 0, 1, 2, 3, 4. It's the 4th position in our block of data, like that. Let me pull this over so we can see more of that. Like that. So that's updating the x position for our vertex. And this needs to be plus equals. There we go. Because we're adding on top of whatever the previous value was. And that's why we have a vector, because the vector, what that will do, oh, I need to put a times here. The vector will make that negative or positive. So if it's going up versus down or left versus right, in this case it's left versus right because we're doing the x coordinate. We're going to have to do some capping here as well. And we can do that inside this function. I don't know if we'll want to keep that inside this function, but yeah, we'll do that. And then this is for the y position, and these should all just be plus 1 of their current values times, I've already lost, speed times vector, and 0, 1, 2, 3, 3. So, okay. I'm just going to put a little note here. Speed times vector. Updated position equals speed times vector. Okay. Just so I remember that order, because this isn't very readable as it is right now. It makes our code shorter, but it's, yeah, definitely not readable. You know what I could do? to make this a little more readable is actually add some variables in here. I don't think it'll slow things down too much. Selected xvec equals this, like that. This will make it more readable. So we can swap that out. X vector int y vec equals this. This is our y vector. And we replace that, and we can do our speed as well. Int x speed equals this. I'm going to cut that out and replace it. X speed times x vect. Yep. And int y speed equals this. 0, 1, 2, 3, 4, 5. Yeah, I was just making sure that that was correct. Okay. There we go. Y speed. And that makes that function, that formula there, that'll make it more readable in case I need to do more with it in the future. And I can get rid of this comment because it's plenty readable. Yeah. So this should actually make our square move, virtually speaking. Visually, we won't see it yet because we have to redraw our line, which we'll just do with the draw shape function up here. This should just work. It will, right now, it'll just fly off the borders of the screen and maybe crash our program, but it should just work. Let's give it a try. So under here, we're going to do move shape, shape 1, and draw shape, shape 1. See what it does. Declaration, Screensaver H33. Oh, that doesn't make any sense. No semicolon at end of structure union. Oh, there it is, right there. It must be something else. Error, expected expression at 120. Ah, there's our problem. Just forgot to put vertex ID right there. There we go. 6, 2. Look at that. It's not clearing our screen each time. That's good to know. But it is working. It was moving them, right? Oh, let's see here. This is a bit of a problem actually because we have to clear the screen each time we move, which I don't think is a cheap operation to do. So we may be up a creek here. Clear. Let's just do a clear screen and just see what it does. See how fast it runs. It may work fine here with one shape. I just don't know how it's going to look with a bunch of lines or how fast it's going to run. Yeah, so it's definitely working. Let's add in some collision for the borders of our screen. That's easy. We just do a check. If we can do that for each one of these, collision check. If I'm going to add a few more variables in here just to make this more readable. Int x position equals this, and int y position equals this. There we go. So if X position X position is less than 0 or X position is greater than 320. We just need to times the actual point in our data. So this times by -1 equals, can I do this? I'm pretty sure I can do this, -1. We just times it by -1. And we do the same thing for the Y position. That should work. Collision check. Pretty sure that's all we need to do. Just need to switch our values around here for Y and change this to 240 rather than 320. Y, and it's 1, I believe, and we just times it by -1. And that should always invert the direction that we're going. So it should bounce now. Let's give it a try, see what it does. See what it does. Hey, it is working. Let's see here. Why isn't it? Oh, because it's gone beyond. I need to actually move that position. Oh, not the position, the vector. So 2 and 3. Let's see what that does. I was doing it to the position. We need to change our vector, not our position. We may need to update the position too. Yeah, because I think what it's doing is it's getting stuck, and so we just need to bump it back. Is there a clever mathematical way I can do that? Detecting where it's at. So if it's less than 0, we need to do a +1 or 2 or something. So on our X, let's go ahead and select our X position. So it's going negative that way. Yeah, and so all we need to do is a plus equals the vector, and that should pop it back in to a boundary where it isn't colliding anymore. Let's see if that works on the X. It should work on the expected. Oh, whoops. There we go. Oh, whoops. That's the wrong. Pretty sure that's the wrong. No. That's correct. That's correct. We're good. Should. Yep. It's working on the X. It's still getting caught on the Y, I think, though. So, yeah, because we haven't added it, duh. So, let's do that. So, it's going to be... Nope. Our Y plus equals the vector. What I should just do is just update these values again, and so it makes it more readable. That's okay. Let's see here. 1. Hopefully this is right. Again, my vector math isn't too good. So why isn't it? Let's be a little more draconian with that offset. Let's do a plus. No, that's not going to work. It's still getting caught. Greater than 320. We invert our vector, which is what we're doing here. Our X vector, we're inverting it. Yeah, that's fine. We're inverting our X vector, correct? And then we take that same vector, because now it's inverted, and because it'll be negative if it goes past 320, so if we add that, it should pull it back. That's correct. Let's just do this. Let's do it times 2. Do it down here as well, might as well. We have the formula set up down here, or the code. There we go. It was still getting caught. We had to bump it 2 pixels back. There we go. It's moving, bouncing. It's not quite mystical yet. We need more lines, right? And it's 8:06. Can I do more lines? And it's going to be kind of plain. It's just going to repeat itself because, and this is what the speed is going to be for later on, because now the speed is uniform. It's all 1. It's going to just keep repeating the same shape, and we'll fix that later. But it is working. That is cool. Yeah, that's working fine. Do I want to try to add more lines? So the way I was going to do the lines is I was just going to record the previous positions in another array, which is going to be tricky, I guess. I don't know if I want to try doing that right now. Let's see here. I need another array, and I just don't think I can do that right now. Shape. Can I do that? I don't think I can. Because I can't. It doesn't. See, the reason why you can't do 2 undefined arrays is because we have to manually define the size when we init it here. It doesn't know where the next one is going to start because it hasn't been, the size of this one hasn't been defined yet. I can use the same one. It's just going to start getting messy. I can do it. I just it's going to take more time because making sure my head is wrapping around things correctly. I can definitely do it in a linear array like this, but is there another way I can do this? Did I delete something? No, I didn't. I just typed that in for some reason. This is the problem with not thinking ahead, is I've kind of painted myself a little bit into a corner. Let's see your shape. Does that make sense? No, that would be really slow if we did it that way. I think the fastest way is just redrawing the line. All of the lines, each frame. I think it's going to be fast enough. I know how we can test it without doing the trail of lines for each shape. We can just do a ton of shapes. But that would require me writing a function that fills in these values. And I don't want to write that function until I decide how I'm going to do those trails. So yeah, I'm kind of in a corner right now. I'm deciding whether to stop the stream right now because it may take too much time to get the rest of this worked out. Gosh. So what I was going to do, we have our points, right? And they're bouncing around. What I was going to do is create an array for the previous 4 frames or something where the line was being drawn. The other way I could do this, no, that won't work because of bounces. It won't work because of bounces. I was thinking I could mathematically calculate those positions, each frame, and just have them draw. But the issue is when you bounce, unless you're keeping track of those vectors, those previous vectors, you won't be able to calculate that mathematically. That would be the fastest way to, or no, actually that wouldn't be the fastest way. Fastest way is just to keep in memory where those previous positions were. I'm pretty sure that's the fastest way to do it because you're just assigning memory rather than doing any math. And that's what I would like to do here. It's just where do I store that data? Yeah. Ooh. That's what I could do. I think I figured it out. We can create another type, def. I don't know if I'm tricking it. I may be tricking it here. This may not work. I don't think I've ever done this before. We create another structure, typedef struct called trail, and we can embed this. Yeah, because it's a pointer, we can do this. We just have to do it before this array. So we just create a member of type trail, and call it and just call it T. We're just going to call it T. Yeah, that's fine. And then we have to, and all this is going to be is another array for the points. And it's just going to match this. It's just not going to have this extra data. It's just going to have XY data times how many trails we want. So, int trail amount. So this is how many trails. We're going to store that little bit of information, and then we're going to create an array called trail positions. And this is just X and Y times by trail amount. That's what that is. So it's going to be 2 times whatever our trail amount is. And it's going to be very similar. In fact, we're going to use our same init function for this for shape for our trails as well. I don't know if we're going to finish this in time, but I'm going to get a start on it, see where we end up. So vertex count, and then we're going to add another here for trail, int trail count, like that. So we've malloced the pointer to trail already doing this, and we filled in that data, and now we can init trail. And so we create yeah, there's another way. I was thinking there might be a clearer way of doing this, but I'm just going to stick to the way I'm doing it. This should work. Positions, yeah. So we create a trail. Yeah, so yeah, we create a trail T. Yeah, this is fine the way we're doing it. Equals malloc size of trail plus, and this is very similar to this. In fact, it's basically the same thing as this up here, except we're going to be switching out vertex amount with, oh, I need to switch these. This needs to be trail amount, and this needs to be trail count, just to be consistent with how we're doing the vertex, the naming convention. It's arbitrary, but I want it to be consistent. Okay, our parentheses are fine there. Good, and now we just need to fill in that data, just like we did before. And we're just gonna run our for loop again, just like this. Like that. And this is S, T, our trail, and trail positions. Like that. We're going to set them all to, this is trail amount, this is trail amount, this is trail amount times 2, like that. And that should be properly initialized. We do need to do another free statement now up here. We can't just do free shape 1 right up front. We have to do free shape 1 T, because that's another structure inside of our structure, and then free shape. And that should do it. and we may write a function to reduce this down to one line eventually. Okay, so we have all those positions. Now we need to write a function that updates those positions, and then we need to update our draw function to go through those positions and draw lines for all those shapes as well. So basically, we're drawing the shape once right now. We'll need to update our draw function so it draws it for how many trails the user has defined for trail amount. So for each shape, it's a times. We're multiplying how many times it takes to draw that, and so this could slow things down a whole lot too. And right now, we need spacing between those trails because right now they're only a pixel apart. This is going to be different for once we have the speed set. No, you know what we're going to do? We're only going to update this information every other frame. Or we can define that every 2 frames, every 3 frames. And so we only draw the trails. Maybe I won't worry about that right now. Because right now, if I just draw it every frame, the trails, it's just going to create a solid block, basically. It will look cool. It'll look like polygons moving around. Maybe let's just do that for now, because I think I know how I can add some spacing to it pretty quickly. If we want to, I'll just change the speed so it's 2 rather than 1 or 3 or 4, so it just moves faster, and that way it's updating those positions so they have some space between the previous frames. Yeah, anyways, that probably didn't make any sense, but let's give this a try. I got about another 12 minutes. Let's see what I can get to here. Where was I? We just init our trail, so those are all set up. We need to write a function that updates, so in our move shape, that's where we're going to update things. So for each vertex, we need to go through and update our trail equivalent. So we have, so for example, if we want to keep 4 trails, we'll have 4 X and Y positions we have to update. And so each time we move our shape, we need to shift our previous values down, get rid of the last value, and update the first value. Okay. So when do we want to do that is the question. We've shifted. Okay, we want to do it before the collision check. So update trails. Trail point positions. Come on. There we go. So we need a for loop. I'm going to just create a new variable here we can use for this one. No, we'll do vertex. Yes, we need vertex ID. So we need to go through, we need to go through each vertex, which we're already doing. We're already going through each vertex. What we're doing is we're going through each trail position for that vertex. So we do need another int ID we can track. This is trail trail point ID equals 0. Trail point ID equals 0, and as long as trail point ID doesn't equal st trail, let's see, your trail count, so our total amount of trails, that will be defined later. Trail count or trail point ID plus plus. Oh, actually, we need to go backwards. Because we need to create an empty space at the top of that array for our newest value. So we actually start at strail count -1, and as long as it doesn't, as long as it's greater than 0, we go down through it. And I think that works. That won't cause a crash, I'm pretty sure. We'll find out. That may cause a crash. We'll see. And now we just need to copy the values from, so st trail positions, and we need our select, let's see here. Our selected, oh, we have to create a new selected, we just got to update this, and we can do that because it's in a new for loop. No, we can't. Int trail selected vertex. I don't want to spend too much time on names right now. Equals, it's just vertex ID times 2 because that's the offset for our trails, our trail data per vertex for each vertex block of data. So trail positions, trail selected vertex, like that, plus 0. So our X, oh, wait. Am I doing this right? I don't think I'm doing this right. This is why I was debating, because I have a lot of names I have to keep track of now for these for loops, and I get all tangled up when this happens. Let's see here. Trail position. No, we're just doing. Okay. It's okay. This just needs to be this. There we go. That's correct. And now we can go trail selected vertex, and it's selecting the last one in the array. And we're going to be doing the X position equals, and then it's S shape vertex data. Oh, no. We're going, it's only the last one. Oh, we need an if statement here. If trail point ID equals 0. So the last one we want to fill in with our latest updated position, but all the rest we just need to shift down. That's why we're doing an if statement. So this will be the case for that, and then everything else we're just shifting down right here. Yeah, like that. And yeah, selected trail selected vertex 0 equals, and it's the same thing, but we're selecting. So right now we're selecting, for example, this is the first loop, we're selecting the last vertex for our trails, and we need to take the value from the second to last one and move it down to here. So the X value for the second to last one goes to the X value of the last one. Yeah, a lot to keep straight. Difficult, very difficult. In fact, what I'm going to do is trail selected vertex int higher or lower. No, those aren't the good right words to use. Trail previous vertex. Yeah, let's just do that. And this just equals selected vertex minus 1. This one, like that. I'm doing all these variables to make it a little bit more readable when I come back to this later. Yeah, I'm just worried I'll forget. But now we can just do previous vertex and take the x value from that, and it just equals that now. And we can do that for the y as well, and it will do that for example, if we have 4, it will do it for 3, 2, 1, and then it'll hit 0, and it'll say, don't worry about shifting that one down. What we're going to do is just take our updated vertex values, position values, and plug that into the trail. Oh, I guess I don't need to do that, do I? Because we're just doing trails. I don't need to do this shift down. I think this is well, I do. I still need to do the shift down. I don't need to save that first set of data. Oh, okay. I need to be doing this before we update. Let's see here. I need to do it here before we update. Pretty sure. Here, selected vertex. Am I using that? I'm not using any of these, I don't think. So yeah, we're fine. I got to do it before we make the move, because we got to save that last position. Yeah, that should work. So I just need to make sure that these are Y, like that. Y, and then up here. So for our last, for our first vertex, when we finally get to that, when we're updating that first point in our trail, our first trail line, that's how I should say that, our first trail line, we just use the current position before we update it again. So our X, and then we go to vertex. Oh, it would be nice to have selected vertex. Let's run that up here first. And our, you know what, let's just move this all back up here. It's okay for us to do this. So, because it's going to be ran anyways. Because we can use these words here really quick. Are the things that made things a little more readable. In fact, it's just these, I think. Oh, no. Wait a second. Did I just lose something? No, that's right. Before we move the primary trail, the primary line shape. I need to come up with a convention to actually talk about this in order to keep the names straight, because I've already mixed names up, so it's not a huge deal, I guess. Oh yeah, we just need to use these X position, because we're getting our current X position here. So we just go X position, Y position, just like that. Y position. Yep, there we go. That should do it. This is selecting the previous one. Yeah, we're getting the previous trail there. We go through, we shift all those, and then we actually update our position for our new line. Yeah, that should work. Good. It's 8:30. I'm technically out of time. But let's see if we can draw this really quick. Draw the shape. We just need to do a for loop. We draw our updated shape, and then we can go through and draw our lines. So let's, yeah, we do that. We're going to do that. We're going to draw our main shape. What is going on here? Where is the end? Oh, I don't have a closing bracket on that. Oh, no, there it is. Oh, that was weird. I just wasn't seeing it. There it is. And then we run another for loop. We can use vertex ID for this. ID equals 0, and we do that for the trails as well. Run through it one more time and do the trails. But yeah, so basically we're copying this and we just update it for the trails. So yeah, this is faster than I thought it would be. Selected vertex, and the offset's 2 in this block of data instead of 6. Remember, we had 6 values here for our vertex, but for our trails, we're copying that data, but we only care about the x and y, and so that array is only in blocks of 2 integers. So it's basically the same thing. We're just doing it twice, and we got to just point it to our trail data. So T, our trails, and whatever we're calling trail positions right there, like that. And selected vertex is fine. We will need to update these. So yeah, we just need to update every instance of this. Like that. Why was this doing... Oh, it's just pointing at our next vertex, so this just needs to be 2 and 3. 3, yeah, that's fine. It's just pointing to the next vertex, then it updates it, just draws the line, like that. This should work. Let's see what I screwed up on. Conflicting types for shape and knit. 67. Oh, I just need to update. Oh, I need to go update some functions here really quick. Declarations. The declarations anyways. And I need to add, we're going to be adding another value to shape and knit. Right here, let's give it just 3 trails for now, trail lines. Yeah, let's see if that got rid of those issues. 81, we are expecting a parentheses, so I'm just missing, I thought I had this correct, but maybe I didn't. That's good. That's good. Oh yeah, I do need one more. There we go. There's that. Oh, it built. That's a good sign. Clear, make, clean, make. Let's make sure everything else is hunky-dory. Looks like it is. Hunky-dory. I don't know why I'm using that word. Unused variable t. Oh, that's not a good sign. 81. Where? Oh, I need to set this st equals t. There we go. Because we're inside this shape and knit, we're creating the structure here. We're mallocing it, and it's just a pointer, and we just have to return it to our pointer. We just need to set the pointer address value here to the one we mallocked here. Hopefully it doesn't get destroyed when we leave this function. That's what I'm worried about. I'm thinking we may have to do another init for the trails, and that won't be hard to set up, but I'm hoping we can just skip that. Okay, looks like everything's fine. Let's see if it doesn't crash. It'd be cool if this worked out of the box. Would have been a pretty Productive day. Yeah, it didn't work out of the box and it crashed. Yeah, so I think this is the issue here. Pretty sure this is the problem. So let's do that really quick. That won't be hard. I'm just going to do a trail init. Trail amount. If I can spell anything, there we go. That was too much of a struggle. Okay, and we just copy. This will trail t equals, yeah, we just need to copy this into here, and this will return t, and trail this st equals trail init trail amount, like that, and that should do that. That should be fine. We do need to declare this new function here, like that. That should do the trick. Let's see what that says. Error, ida undeclared, s undeclared. There's just some things I have to update here. Get rid of that. Needs just anti equals 0. Oh, whoops. Where did I go? Like that. Well, let's see if that keeps it from crashing. Yeah, there's definitely something else wrong. No, it's still crashing. Okay, this is valid. I know this shouldn't be causing us, pretty sure it shouldn't be causing us any problems. So trail amount times 2, because we're initializing it like before. It's a very similar initialization. Just double checking to make sure there isn't a typo somewhere. Okay, so this is good. I am not concerned with this. There's probably just an issue with drawing our shape or moving our shape. So let's make sure our initialization is good by commenting out all of our trail stuff just to make sure it's still running like we had it before. Yep, it's working fine. Let's add in the move shape, because that isn't going to be drawing anything to the screen. It's just updating positions. 6.2. Okay, so our problem is somewhere in there. And I think what it is it's us going backwards in the loop. I'm not doing that correctly. Equals trail count. Pretty sure. Because if I comment anywhere where we're using this, where we're trying to access the array, so these, I think it will start working. Because yeah, it will, because we're just setting variables. So yeah, this should work. But as soon as I bring one of these in, it should crash. Oh no, it's not. That's a good sign, because this could just be I mistyped something. This is how you debug without a debugger, by the way, is you just comment and uncomment lines of code until you can narrow down where the problem is. So it's somewhere down here. I don't have this right. So our current vertex x position is equal to the previous vertex x position. We're just shifting everything down. I wonder, Let's just see if this works one at a time. Yeah, so it's having a problem with that. It shouldn't be... minus minus. I am doing a minus minus. That's good. Is greater than 0. Yeah, that's fine. As soon as it hits -1, see, it'll do a minus. It'll do a minus minus one more time and check against this, and it'll realize, oh, it's -1, so we need to just break out of this loop. So we're fine there. Trail point equals. Yeah, that's fine. We're starting at the right value there. That's good. I'm going to wrap this in parentheses just to be safe. I'm pretty sure we're fine, but I like doing that. It got me a bit concerned. Wonder if my Jag's display is dying. It keeps switching or flickering on and off. Okay, trail position, trail previous vertex position. Let's make, yeah, this should be fine because we're selecting the last one and then we're just minusing 1 on it. Let's see here, previous. Oh no, this isn't correct. It's -2. Because we have 2 points of data for each vertex. It's -2. Let's see if that helps. I don't see why that would be crashing anything though. Yeah, that shouldn't be. What was there before shouldn't have been crashing anything, but there's something really awry here. Previous trail selected position. Huh. What is going on? Trail positions. We select the previous one, trail previous position. Let's see here. Yeah, because we're going up in the array and assigning it, assigning it, assigning it. Yeah, this should be working. Position. +0. +1. We don't even have the other one in yet. Like, that shouldn't be a problem. I am not sure. Trail positions. Why would it be having an issue with that? Well, I guess it could still be how we're allotting that data. Return T, return S equals trail init. Yeah, that's fine. It's just a pointer to another block of data. That shouldn't be causing any problems. Because it's allotting that memory. It's just an address to a pointer. Trail amount, size of integer. Yeah, that's good. And then we go through. We assign everything to 0. Yeah, that should be fine. Huh. We're doing nothing in our draw shape, so with the trail lines, so that shouldn't be crashing anything. Here, let's do this. Just no. I gotta keep the move at least going. Yeah, there's nothing. It's definitely not the draw function. There isn't anything specific that isn't commented out already that would be causing the problem, because it's just what our code was before we started working on the trails. So yeah, that's fine. It's definitely this here. Not changing anything. No, and that's just the collision data. has to be the way. Here, I'm going to do a quick search for C code specifically. C code backwards for loop. To reverse a number doing... No, that's not what... It's to do with an unsigned integer. Yeah, he's doing it the same way. I equals or n minus 1. Pointless comparison before I had one of the... Let's see here. How about for I equals n and I minus minus is greater than 0. Do stuff with I. Oh. So, wow, that's cool. I've never seen that before. So, I know you guys didn't see this, but the way they do it is just this, and then they do trail point ID minus minus is greater than that, and then you can drop this. Just leave that blank. See if that works. It's not crashing. It's a good sign. We're not going to see anything right now because our... Oh, no. We should be seeing... Yeah, we should be seeing our shape bouncing around just without the trails. So I think it is still crashing. Yeah, so that's what we should be seeing. D. So this is causing a problem. Trail selected vertex equals... Is this right? Trail... Oh, no, this isn't right. Do I need this? I don't think I need this for loop now that I think about it. Let's see here. Oh, sorry about that. Yeah, I don't think I need this for loop. Oh, no. I do because I'm sorting. That's what's going on. I need to write this in. Shift values down in array. That's what I'm doing this for. So yeah, I do need this other for loop. We're going through each vertex. Yeah, that's fine. That's definitely fine. I'm curious. Let me double check, make sure I'm doing that for loop correctly. Pretty sure I am. Minus minus is greater than 0, do stuff with I. And it's typically the length of an array, so in most cases you don't want I equals to n. As far as I'm concerned, this is standard idiom for reverse loop. I'm surprised people haven't met it before. You can even write it as minus minus is greater than, which will tell visually the intention. Okay. Yeah, I'm definitely doing this right up here. This should be working just fine. Trail selected vertex. So when it hits 0, it's going to be times 2, still 0. That's fine. So these are correct. I don't know why this would be crashing it. Huh. The only thing I can figure is because I'm doing a reverse lookup in that array, but it shouldn't be a problem because we have the memory allocated. It should not care about that. I'm not sure what to do here. Well, it was worth a try. I've run out of time. I gotta get off here soon. The problem is definitely here, though. Yeah. I just don't know why it doesn't like what I'm doing here. -2, that's correct. Equals X position. Yeah, that's fine. Trail position, trail selected vertex. +0, +1, yeah, that's fine. Yeah, this should be working. Let's check something here really quick. I'm just wondering if I'm still not allocating the memory for the trails correctly. And we can do a similar test to what we did before by just seeing what values are in there. In fact, we can just look at the first two values. Let's see here. Where am I going? Up at the top. There we go. And Mystic Screensaver. What we're going to do is we're just going to print to the screen every frame 2 values. %d, %d, and those 2 values are going to be shape 1, trails, trail positions, and we're going to do the X positions of the first and second vertex. Trail, am I spelling that right? Just copy and paste it. There we go. Which is values 0 and 2. So copy this one more time. And 2, like that. That should work. I'm going to put a line. No, I'm not going to line break it. Yes, I am actually. That way it refreshes every frame. Let's see what that shows here to begin with. See if it shows anything. It crashes before that. This is why I'm thinking we aren't allocating it correctly. There is something wrong with our structure. But it's running otherwise. That is weird. We know it runs if I comment out those. 6.2. Yeah, so it's not going to update because we haven't run it yet. But as soon as we try to assign a value to it, it crashes. I must be writing a value somewhere bad in memory. So I think what's going on is I need to do this trail in it outside of our shape in it. And that's okay, we can do that. We just remove this from here. That may be causing a problem. I don't know for sure. Trail init or shape init. There you are. And we're going to do a shape init. We just have to take this and this and 3. We need to remove this. Update our functions so they don't need that anymore. There and there. That should work. Well, it should make. Oh, there's something. It's working. Why is it so slow? Shouldn't be that slow. Draw shape. Draw shape. Huh. It has to be this reverse for loop that I'm doing that's causing the problem. We need to do this, so in order to... I mean, I could manually input all the values. I don't want to do that, though, if I don't have to. Why would that be causing a problem? That is bizarre. Trail point. Oh, I figured it out. This needs to be... Yeah, that's our problem. No, that's right. This is right. Trail count. That's correct. That's our max amount of trails. So it's going, in this case, it's going through 4 different trails and shifting those values. That's correct. That's good. Pretty sure. Let's do this. We're going to print... I don't know if this is actually going to show up, though. Let's just type it in. Here, f print f debug console, and I want it to just print an integer, and I want it to be trail point ID, like that. I just want to make sure our for loop is working. Yeah, it isn't working. That is a problem. I'm going out of memory or something. Yeah, it does not like this. Is there another way I can do a reverse for loop? I swear I've done one before and gotten it to work. I just don't know. Or let's see here. Loop index equals n. Well, that doesn't work for 0. That breaks. Deleted comment when trying to delete my own. Got mine from cache. A classic example. Note that if you use C++ as well as C, using is a good habit to get when you switch using iterators where it may not be available. I does not equal 0 minus minus. Do something with I minus 1. That's how everybody's doing this, is I minus 1. Huh. Yeah, we're really close, Matt. Let's equals trail count. Let's go ahead and switch this to one of the other examples. I don't like it, but it does work. I just don't think it's going to work with 0, is it? So what we basically have to do is anywhere where trail point ID is defined, we do a -1. And that way we're not accidentally accessing something beyond the array. Yeah, that's correct. That's fine. Let's just take a look at that, see what it says really quick. We shouldn't be getting that really big number. Oh, whoops, wrong one. 2. There we go. It's still a huge number for some reason. It shouldn't be that way. Here I'm going to do another for loop. Int debug I equals 0 for debug I equals 0, debug I doesn't equal 45. This is just to slow it down. Debug I plus plus vsync like that. Why is that value so big? That's why it's crashing. It shouldn't be that big though. Trail point ID equals S trail count. Oh, we're not, duh. I'm not initializing it. See? So right here, we're not, this member of this trail struct, we're not actually setting it with trail amount. That's why. That was our problem. Ugh. Just, it's an oversight. Trail amount. There we go. That's, oh, whoops. Trail, see, I almost screwed up again. Equals T trail, or no, just trail amount. You got it. You got it, Will. You got it. That should be a small number now. Yeah, there we go. That's exactly what we want. 3, 2, 1. It's not hitting 0. That's what I was worried about when I switched that for loop. So let's go ahead and switch it back. I'm interested in trying this because I've never tried that before. See if it works. So it should go 3, 2, 1, 0. That's what I'm expecting here. It's not hitting 3. So if I do... Why is it so hard to do a reverse for loop? It's frustrating. Oh, let's see here. I know a way to do it. It feels messy. I'm just seeing if there might be a more clever way of doing it. Yeah, that doesn't work because it's this should work. It should be hitting 3. Oh no, this is correct. It should be doing, because I only have 3. I'm not doing 4 trails. I'm doing 3 trails. So yeah, we're good. We're good on that. That's working. So let's uncomment these really quick and see if it crashes, because it was crashing before, right? We had those uncommented. Okay, we're fine. It's working now. Let me get rid of this debug stuff. We don't need that. Uncomment these. Make sure we're still not crashing. I can probably revert my init statement, get rid of that trail init thing if I wanted to, but we'll keep it separate for now. There we go. That's working. Now we just uncomment our draw code and we should have trails. One little mistake, man. Oh, we got something. It's kind of working. It's drawing the other lines. It's going fast too. It's not too slow. I think there's a little bit of vertical tearing there going on. Screen tearing. But it is working. It's just not drawing them in the right points for some reason. I wonder why those are sticking to the left like that. Weird. Oh, see, now I want to spend time doing this, but I really do need to get off. Let me take just a quick look here. 2 trail position. That's our first point. Yeah, it's just going through the vertexes, right? Yeah, it's going through that twice. Going through all the vertices twice. One for the shape and then one for the trails. Oh, but it isn't drawing for all 3 trails. So for int trail trail point ID. Oh, let's see here. This needs to be outside, actually, this for loop, because we need to go through each trail, treat each trail as its shape as well, and that's determined by how many trails we want. So in this case 3, we got to do that first. Int trail, what did I call it? Trail point ID, or let's do just trail ID for this. 0 trail ID equals 0, and trail ID doesn't equal st trail count, so we don't want to go beyond how many trails we want, and trail ID plus plus. I don't think I did this right. Yeah, I don't think I did this right. This is correct. This for loop's correct. We need to do this, but now we need to offset it. Yeah. Yep. So we're basically only storing enough for one trail right now. We didn't take into account the variable amount of trails that the user might specify. So let's go look at our trail init. Yeah, so I'm only doing it. Yeah, I'm only doing it for, no, I'm not even doing it for one trail. Oh, excuse me. In fact, yeah, we do need to move this back into, well, I'm going to keep it out. And what we're going to do is we're going to pass in a shape S like that, so we can get how many points are in our shape, how many vertices are in our shape. Yeah, we didn't do this right. So size of trail amount times 2 times the vertex, the amount of vertexes, which is S vertex count. There we go. And then our offset is going to be a little bit weird when we do this, because we have to refer back to vertex count each time and count that times size. Yeah, so that's the right size now. But we do need to do trail amount time trail amount. Yes, that's correct. We take this, so this initializes correctly now. Grab that one more set of parentheses like that. Okay, so now we're allocating enough memory for all the trails and all the vertexes in those trails for the X and Y data for each one of those trails. And then in our move, this is all going to update now too. We just have to adjust our offsets. So our selected trail vertex, this will be in another for loop. Let's see here. Yeah, this is for each vertex, but we need to now select each trail. So each sub-shape of our shape, essentially. So int trail ID 0, and for, oh no, we're already doing that here with our vertex. Yeah, that's fine. So we already have this. Oh, no, we don't. This is trail ID now. That's where I'm confused. Trail ID, this is trail ID. So this is, oh, no. This is the points. Go back. Because those are shifting, we do need to go through each. That's what it is. This needs to be vertex count. Vertex count, like that, equals vertex trail. And I'm going to change this to vertex. Vertex to make it more readable. Vertex. I think that's it. Yep, that's it there. And now we need to go through our trails. Yeah, okay, I think I got this ironed out. Trail ID for trail ID equals 0. And as long as trail ID does not equal ST trail count. Yeah, that's right. Trail ID plus. Wrap that in here because we have to update the position for all of our trails for however many trails there are. And then our offset, so this is different. Our trail positions by S vertex count times by vertex count times by trail count times by trail count. There we go. Okay, so yeah, that's so to select our position, we first have to get our trail ID or our which trail we're doing, and we do that with trail ID. So trail ID times by whatever our size is, and that's going to be 2 times the vertex count. So 2 times, whoops, let's see here. I'm going to separate that. So trail ID, yeah, 2 times, yeah, it's just 2 times S vertex count, like that, plus trail vertex ID times 2. It gets us our offset within that. Sorry, within that. So we have a trail, set up a block of data that's trail, which is every vertex, and every vertex in that has, in this case, 3 values, position values that we're saving. Ugh, that is confusing. I hope I got this worked out. That's fine. This works fine here, because once we're in there, we just do -2, and that's going to be 0. Yep, that's fine. That should all be fine now. That's what this was for. This should be good. Our draw routine, did we get that updated? I don't think we got it all updated. We're going through each vertex. Okay, so we just need to update our selected vertex. Yeah, so we need to do the same thing here. Yeah, so we just take this. It's this right here. This should do it. Hopefully. We'll see. Like that. I'm gonna wrap this in parentheses too. So if that's 0, vertex count. Yeah, that's correct. That gives us our offset. Yeah, that's fine. Plus this is our X offset on that row. Yeah, that's good. Pretty sure that's all we need to do here. Pretty sure. I'm gonna wrap this in parentheses just to make sure I'm forcing the order correctly. This is still -2. It won't run on 0, which is correct. Yeah. Well, here goes nothing. Conflicting types for trail init. Oh, that's right. We updated trail init to pass in the shape, and we're going to have to update that in our loop as well. Shape trail init. Pass in shape 1 like that, and we may recombine these later just to simplify the code so there aren't so many steps to initialize things. Expected go 16. Oh, whoops. There we go. There's that. Too many arguments. Oh, there we go. 93. Expected parentheses before token. Do I need another? Gosh, I have so many going on here. It is a mess. Let's add one more. Trail amount. Yeah, that's correct. Trail ID undeclared. Oh, I just didn't capitalize it. Go 138. Trail I capital D. Well, hey, I think we're closer. You can definitely see it. It's there. If I set our speeds to 2 on all of our points, we should see some space between it. It's having a problem with the wraparound or something. We are close though. 6.2. Oh, I didn't like that. Oh, it's because our speed is not good. Let's see here. Where was that? Collision check ×2. Oh, that should be working actually. 3. I shouldn't have to do that, but 6.2. Ah, it's still getting stuck. Let's see here. I am shift values. We set it, we invert it, and then, yeah, that should be working. Why isn't this working? Yeah, I'm gonna have to figure out that speed stuff too. We are getting close though. That worked. It's not ideal, but yeah, so you can see a little bit of space going on there. It's screwing up on one of the lines though for some reason. Not sure why. On our draw routine or our draw function, move shape, our draw shape function, it's going through trail ID. Yeah, it's just going through normally. first point. If vertex ID equals vertex count minus 1, then the second point just goes back. Oh, there's our problem. This is our problem right here. We can't do this because the offset isn't correct. We have to run this again, basically. Equals. Oh, we just set it to trail ID plus, like that. There we go. That should do that. That should help. Oh, oops, wrong one. Wrong one. No, not the matrix. Still didn't help. Behavior's a little bit different though. Looks like we have an inverted value, like we're putting a y in an x or an x in a y position. Our trail is there though. Yeah, there's just something wrong with my draw routine at this point. Possibly with my updating my move as well. I'll need to review that. Pretty sure we have that correct though, because we get our trail offset in our data block. Where is that being set? Okay, so right there. For example, if it's 0, this just ends up 0, and then it's +2, whatever our vertex ID. Yeah, pretty sure that's correct. If it's 0, it just takes the current vertex. Yeah, and sets the current x position. Previous position. Oh. No, this is right. This is right as well. It just minus, yeah, because that's no, that isn't right. Let's see here. Trail ID, vertex count, times. No, this isn't correct. Am I still not initializing this correctly? I have a 3-dimensional array going on here, I'm pretty sure. That's what's throwing me off. Trail amount. So there's 3 sets. 3 sets of data for the vertex count. Yeah, so it is a 3-dimensional array. That's what's throwing me off here, and I'm not selecting appropriately. Shift values. It's right here is the issue. So yeah, that's correct. Okay, yeah. Vertex we need to minus. It's it's this right here. We got to update this. Minus this. Pretty sure. Like that. Ugh. Arrays, man. Nope, that just made it worse. Okay, I gotta get off though. Yeah, it's the problem's in there somewhere. It's how I'm organizing my data and then selecting that data. I know what the problem is. I just need to find out where it is. I'm not selecting the data correctly and updating it in the right positions in our data block. But I think this is going to work though. It's drawing that stuff pretty fast. This is the emulator, though. We do need to try it on real hardware eventually. But it is working. So, yeah, 95% there, Matt. So we're really close to getting it. And once we get this set up, like with the trails with one shape, it's really easy to do the other shapes. And so the rest of this is going to be easy to set up once I get this figured out. And so we'll tackle it again tomorrow morning. It might be a little bit boring tomorrow morning, but to begin with, but then we'll get it ironed out and we'll get a options menu set up for random colors or selecting colors for a couple shapes, maybe even more shapes. We'll see. Anyways, we're there. Thanks for joining me. I gotta go. I went like an hour over what I should have. Hope you enjoyed it. And we will see you tomorrow morning, same time. Goodbye.